Hi, welcome back. In this video, we're going to look at how we can use our part one or our part A problems to help us answer the B problems, which is some of the same skills we can use when we're taking our final exam or even just doing the practice test. Okay, so the scale factor of figure x to y is 1 to 7.5. Find the perimeter of y. Okay, and then when I look here, I can see this one was also finding the perimeter. I've got my up and my down arrows. So you know what? I'm going to do the same thing. I'm going to say one of these is up, one of these is down. Okay, and then my scale factor from x to y, so x is up, y is down, that's perfect, is 1 to 7.5. And then I had an equal, so I did my 4 to my 8, and then I had my equals and I did my perimeters. So 17 over x. On this one, my perimeters are going to be 15 over x. And then what did I do? I cross multiplied. So I'm going to do the exact same thing. I'm going to cross multiply. So this time, when I cross multiply, I'm going to get 1 times x. That's nice. I'm not going to have to divide anything out. And then 7.5 times 15. And my answer is 112.5. And these are, this time I do have unit. Oh, I did have units on this one. They were centimeters. These are inches. Okay, let's look at 2. On 2, find x. And if I look at my two pictures and I compare them, I can see they're very similar. My triangle is just pointing in a different way. My two legs that are the same, I had 12, now I have 15. And I had 10, now I have 22. I took that 10 and I divided it into 2 equal pieces. So 11 and 11. And then I said, all right, I'm going to be finding a leg with a minus sign in here. And then my 12 was one of the sides. So that's my 15 on this picture. And then my 5 was the bottom that I divided in half. So that's now 11. So then x equals, I must have put this in the calculator, the square root of 15 squared minus 11 squared. And I get, I'm going to round this to 3 places, 10.198. And I don't know my units, so just units. Okay. Let's look at 3B. An anchor line for a tower needs to be replaced. The tower is 96 feet tall. The anchor line is 105 feet long. How far away from the tower will it be placed? Okay, so I can see over here, there was a completely different type of problem. I'm trying to find treasure on this one. Here I've got a tower that I'm replacing an anchor line for. But notice in both cases, I have the diagonal, I have the hypotenuse, I know how long it is, and then I have one of my legs, and I'm trying to find the other leg, right? So it's going to be the same process. My leg, square root, notice I subtracted. The 40 went in first. That's the one across from the right angle. So my 105 is going to go in first. And then my 96. So that x, the leg, square root 105 squared minus 96 squared gives me, I don't get a nice even number this time, 42.532. And these are feet. Okay. So again, using those examples, it kind of puts me in the right mind frame to go, okay, I know where I'm headed. I know what I'm doing. So as soon as I look at this one, I go, oh, I know I'm going to be using trig because I can see that's Okatoa. Okay. Now the calculator, I still have it open from the when I did the A problems, but I'm just going to hit mode and make sure it still says degree, and it does. If it didn't, I would just arrow down and over to highlight degree and hit enter. And then second and mode again will take me back to my main screen, and now I'm in degree mode. Okay. Then I can see I used my smiley face on the angle that I know. And then coming out of there is a hypotenuse and an adjacent side. The hypotenuse, the adjacent. The side I have to yell at all the way across is on the opposite side of the triangle. So then I can see I circled the x and I circled the 10.8. And then I checked off what I circled. So my adjacent and my opposite. So this time I'm not going to be using sine. I'm going to be using tangent of 50.1 equals opposite over adjacent. My opposite is x over my adjacent is 5. And then I can see I put the left side over 1 and I cross multiplied. Now here the problem changes a little bit from the last one because when I cross multiply, x times 1 is just x. And then 5 times the tangent of 50.1. Notice I have x equals, whereas over here I had x times. So since I'm already x equals, I can go straight to the calculator and do 5 times the tangent of 50.1. Close that parentheses. Sometimes it's important. And hit enter. And my value for x equals 5.9799, so 5.98 if I round correctly. And these are units. Okay, again, those parentheses are kind of important because when you cross multiply, if you multiply this as tangent of 50.1 times 5 instead of 5 times the tangent of 50.1, and you use your parentheses, tangent of 50.1, close parentheses, times 5, you get the correct answer. But if you do tangent of 50.1 times 5, you don't get the same answer because it didn't know to stop the tangent there. It put that times 5 inside the parentheses. Okay, so make sure, sometimes you need that parentheses, make sure you're using it when appropriate. Okay, all right, let's look at B. Again, I can see I use SOHCAHTOA on my problem there, so you know what? And it tells me about my degrees. My picture is very similar. I've got an x degrees and 2 sides, an x degree, 2 sides, a right angle, a right angle. SOHCAHTOA. And notice I used an inverse, so I know I'm going to be using inverse, but first I need to figure out which inverse I'm going to be using. So here's my smiley face at the angle x. Coming out of that angle is the hypotenuse and an adjacent side. The hypotenuse is across from the right angle, which means 6 is adjacent, and all the way on the opposite side is the opposite side. So then we circle the 2 sides that we know, adjacent and hypotenuse. Adjacent and hypotenuse. So I'm going to be using cosine, but the inverse version of it this time. So the inverse cosine of adjacent over hypotenuse, 6 over 10, is going to give me my value for x. So my inverse cosine, second cosine, of 6 divided by 10 gives me, notice I closed my parentheses, I put that seatbelt on, and I get, it says to the nearest degree, so I can round to the whole number, I'm going to get 53 degrees. Okay, let's look at 6. All right, so on 6, I use this idea of alternate interior angles. Let's see if we can just do that again. So do I know the alternate interior angle for x? Well, if I come across this diagonal and think of it as a transversal, here the x is below it, so I want to look on the alternate side of it, so I want to look above it, and yep, sure enough, x is 42 degrees. Easy peasy, especially when you already have the example. Use your examples. You're going to have 2 examples of every single problem from the practice assessment for part 1, and then after that you'll have 3 examples for the actual final exam. Okay? All right, so the next one, true or false, consecutive sides in a rectangle are perpendicular. So remember, consecutive means right next to each other, and then perpendicular means 90. So if I think about a rectangle, I know all the angles here are 90. So when it says consecutive sides, that means 2 sides that are right next to each other. So for example, this side right here, and then either the top or the bottom, right? These 2 sides would be consecutive because they're next to each other. Well, are they perpendicular? Yes, they are. Is that going to be true for any of those? Instead of this one, what if I said instead of that one, what about this one? So here and this consecutive side. Are those also perpendicular? Do they intersect at 90? Yes, they do. So that works. Okay. What if I wasn't looking at those two? What if I was looking at this bottom one and the right-hand side? Are these two consecutive sides? Are they intersecting at 90? Are they perpendicular? Yes, they are, right? It doesn't matter which two sides next to each other I pick, they're always going to intersect at 90. So this is a true statement. Okay, so a little bit harder on true false statements to use the examples, but just remember, sketch yourself a triangle and see if you can prove this sentence false. If you can prove it false, then you know it's a false statement. If you can't, if every single place you look at it, it's true, then you know it's a true statement. Okay? All right, let's look at 8. For the isosceles trapezoid, find x. Let's see what I did over here. X was 45. These two bottom pieces were 45. This time I've got the two top pieces, but it's just the same thing, kind of upside down. So x is 38. Easy peasy. Moving on. All right, number 9. I have a kite just like I did last time. And I noted last time that I had a top and I had a tail. And then I had two side angles, and I added an X in my picture because these two angles had to be equal, I put. And then let's see what I did. I added together the 110 and the 22, the top and the tail. So let's do that. 115 plus 31. 6, 4, 1. Then what did I do with that number? I took it away from 360 because there's 360 degrees in a four-sided figure. 360 minus 146 is 214. And then what did I do? Then I divided that by 2 because it has to go into these two equal angles. Divided by 2, and x equals 107 degrees. All right, 2 more. Let's look at 10. What is the coordinate notation for the translation b 15.2 to b prime 7.8? So let's see what we did on the last one. We started with xy goes to, I forgot my arrow. And then x minus 6, because from 2 to negative 4, I'm taking away 6. But let's look at this one. From 15 down to 7, I am still getting smaller, so I am subtracting. How much am I subtracting? I'm subtracting 8. Okay, then y plus 8 is what I had because I went from 7 up to 15. Here I'm going to go from 2 up to 8. So I'm increasing also. I'm increasing by 6. There is my coordinate notation. Okay. All right, last but not least, number 11. The figure below will be reflected across the x-axis. So that's different because this one was y-axis, this one is x-axis. So this time, I'm reflecting across the x-axis, this one here. Okay, so I did show you last time you can use your formula chart to do that. My formula chart says when I'm reflecting across the x-axis, xy becomes x, the opposite of y, x, the opposite of y. So when I look at, we're looking at the coordinates of t. T is at negative 2, 3. And so t prime is going to be the x, negative 2, and then the opposite of y, negative 3. And if we do what we did before, I'm erasing this because it's going to be in my way, trying to count. I'll write it out of the way. Negative 2, 3. I need to go down 1, 2, 3 to get to the line. So then I'm going to go down 1, 2, 3 further. And I can see I'm right here at negative 2, negative 3, for my t prime. So again, you can either do it using the coordinate rules from the formula chart, or you can just count on your graph. You just have to pay attention to the x-axis or the y-axis on that one. Okay, so hopefully going through this a second time, you'll see we made it through a little bit faster. And you'll also see that you can use your examples to help you figure out the process to answer the questions on the exam. All right, thank you so much for watching.